All right, in the second video, we're going to talk about minimum and maximum points. So I'm going to draw you just a little sketch to go off of. Let's say we have an odd function like that. We're going to define two new things. We've got a point that looks something like that. That point, it's like a little hill in the graph. We call this point a relative maximum value. So it's not a total maximum, like it's not the highest point ever, but it's the highest point in the general vicinity. So that's what that word relative means. Relative to the other points around it, it's higher. And then you have these little valleys like that, and so that is a relative minimum. So again, not the lowest point that the graph ever hits, but it's lower than the points around it. Relatively speaking, it is the lowest point in the general vicinity. So those peaks and valleys, we call them relative maxes and relative mins. Another word that we have for those is turning points. So we've got those right there. So maxes and mins are also known as turning points. So turning points basically means when the graph kind of flips and changes direction. So here it's headed up. There's a turning point. It flips and heads down. There's a turning point. It flips and heads up. All right, so this is super, super important. The graph of a polynomial has at most n-1 turning points. And we actually mentioned that in one of the previous videos when we were doing these general shapes. So I want to remind you of this. We talked about how this is of degree 1. 1 minus 1 is 0, and so it never changes here. This is degree 2, so 1 less is 1. It's got 1 turning point. This is degree 3, so it's got 2 turning points. Degree 4 has 3 turning points, and degree 5 has 4 turning points. So that's what this line means. All right, that has at most n-1 turning points. Super important. All right, so we're going to graph this function. We're going to do it with that menu define, like we did in the previous video. So we're going to set up, like I said, just our classic table here. If we need to add on any more values, we will. Okay, so we know that this is an positive odd function, so we should see it do something like this. All right, off to the left it should be going down to negative infinity, off to the right it should be going up to positive infinity, so we want to make sure we see that pattern happen on the table. Okay, so we are going to do that menu actions, one for actions and then one for define, and then just plug this function in. So f of x equals x to the third minus 3x squared plus 5. Okay, then we can just plug these values in. So f of negative 3 is negative 49. Okay, so we definitely see it going off towards that negative infinity. F of negative 2 is negative 15. F of negative 1 is 1. F of 0 is 5. F of 1 is 3. F of 2 is 1, and f of 3 is 5. Okay, so let's add one more just to show that it does keep growing after that point. There we go. So we see the 21, so you can see it's going off to positive infinity. All right, so let's give a quick sketch. Okay, so these values are really, really, really low. Let's scale by 2. Negative 2, 4, 6, 8, 10, 12, 14. So we can sketch this. Negative 2 be down at negative 15. Negative 1 is at 1. 0, 5. 1, 3. 2, 1. 3, 5. And then 4, 21 would be way up here. All right, so we see it does something like this. Okay, so that's very similar to the shape we were expecting. Now here's the important part. Estimate the x-coordinates at which the relative maxima and minimum occur. Okay, so you can see there are these two turning points. Okay, so we think the max occurs, and we're not necessarily going to say it occurs at 0 because we didn't plug any of the decimals. Like, we're not sure that it happens there, but we know it happens near 0. Okay, so somewhere around there. And then the minimum is happening somewhere around 2. Okay, so that's what you guys do for that. You should identify max and mins, and you can see on this table, see how the values are going up, they're going up, they're going up, and then they go down. And so this was actually a change right here. And they're going down, and then they go back up. And so that was another change here. So at 0 and at 2, we had those turning points approximately somewhere near those x values. Okay, example 4, we're going to look at another graph that we can see based on this equation right here. So the weight of a patient during a 7-week illness. Okay, so we can't have negative values here. That wouldn't make sense because we got to go within the context of the problem. It says a 7-week illness, so we're going to plug in 1 through 7. Okay, so and then W. So let's go 0 through 7. Okay, so we're going to plug in this function. So menu, 1 for actions, 1 for define, and we can type in W of n, just type it exactly the way it's written, equals 0.1 n to the third minus 0.6 n to the second plus 110. Well, it doesn't like that. Okay, I must have W defined somewhere else, so you don't need to change this. I'm just going to change it and see if I can get a different variable. Let's just try Y. No. Anything? B? Yep. Okay, so you can see I have a ton of pages open, so W must have been used already. So normally you'd be typing W, but I'm going to type B of 0. It's 110. B of 1, 109.5. So this is the weight. So you can see they're losing weight at this point. 108.4. B of 3, 107.3, still losing weight. Let's see if we get a turning point anywhere. Nope, 106.8. 5. There we go. That was our turning point. So now they start gaining weight again. Oops, not W. B of 6, 110. Okay, back up to normal. And 114. Okay. So those are the values that we are looking at. So we've got these. We're going to graph the function. So we only need these positive values, 1 through 7. And then we're going to put a little split in the graph here so that we can start at like 106. 6, 7, 8, 9, 10. Okay, so our patient starts at 110, and then 1 week later, 109.5. 1 week later, 108.4. 107.3. 106.8. Back up a little bit to 107.5. Up a little bit more to 110. And then 114.9 would be up here. All right, so it's going to look something like this. You just connect the dots. Okay, so something like that. All right, so that's the first part. That's the graph. We've got some questions. Describe the turning points of the graph and its end behavior. Okay, so turning point. Near, and what was that? That was week 4. Week 4 was when we started seeing a positive change, starting to gain weight back. And then the end behavior, we can say that the function approaches infinity as x approaches infinity. And we're not going to talk about negative infinity because negative infinity doesn't make any sense in this context. Okay, what trends in the patient's weight does the graph suggest? You can see that they're losing weight for a while and then started to gain weight back. Okay, so patient lost weight for 4 weeks. Then started gaining it back. Okay, and then will it continue indefinitely? No, probably not. We can probably assume that they might gain weight for a little while since they're getting healthy again, but it's not reasonable to assume that the patient's weight will rise indefinitely. Okay, so let's say it is unlikely the weight will rise indefinitely. Oops, unlikely. The weight will rise indefinitely. I suppose it's possible, but probably not.